Okay, it's time to go. We're good? Let me make sure. Okay, good. I had to fuck around with my mic settings a little bit. Or, well, I have these speakers. One is right here. And I was adjusting stuff. I guess it was just output, not input, actually. But, okie dokie. Let's go. What are we doing? We're doing iterators, apparently. Last time, I wasn't recording because my buddy came over, and I don't want to record when I got people over. Last night, I was, what did we do? I finished selection sort. Oh, did I smudge these? Oh, it's good. It's just like sunlight coming in or something, I don't know. What do we do with selection sort? Oh, we did selection sort, and then we reversed it, so to sort from greatest to least, bro. I've been saying greatest to least. Oh, greatest to least. I just don't say least very often. And then, what else? Then we did bubble sort, and bubble sort looks like, basically what you first do is loop through an array to check if it's sorted. So basically what you do is you check every array I element and check if it's greater than array I plus 1. And the point there is you're comparing one element to the next element, and you go until I is less than the size of the array minus 1. Not the size of the array, because if you go all the way up to the last index, which is the size of the array, well, the last index is less than the size of the array, because if the array size is 8, the last index is 7. So normally you go up to the last thing and then you do something there, but in this case, we want to go up to the second to last thing, because in that case, we're comparing the second to last element to the last element. If you did one more, we'd be comparing the last element to there is no last element. We would be out of bounds. So instead, we do this while we're under the size minus 1, basically. And you could set size minus 1 to be the length, and then you could say, yeah, that's it. Excuse me. So we check every time, and if the first element is less than or is greater than the second element, then we swap them. Swap array I and array I plus 1. And we pass these integer elements by reference to a function called swap that takes whatever we could have it set up as a template, basically swaps two places, the values from two places of memory of some type. They're both strings, they're both characters, they're both arrays of characters, they're both arrays of integers, whatever. In our case, it's an array of integers. Cool. And if the swap happens, then flag the array as unsorted and break. So we flag the array by setting a boolean is sorted to be false. By default, it's set to be true, so our flag equals, or we'll say sorted flag equals true, but in this case, we're going to say sorted flag is false, and then we're going to break. And then after, we can check to see, is the sorted flag still true? If sorted flag, that means that we went through this whole array, never set it to false, because it was always, every element was always less than the next element, which means it's sorted. If it's still true because it's true by default, meaning we never overrode it to make it false, cool. Sorted flag, then return. Or print is sorted, and then return. After, if it's not sorted, instead we don't need to do an else statement here, because if it was sorted, we would have returned. So the only way that we can access subsequent code is if it wasn't sorted. So then we loop through array. Again, same thing, comparing one element to the next element. And if, let's see, oh, we haven't even done this. Wait, hold on. This is actually later. This is the swap part. And if it's greater than, then we flag the array as unsorted. And we do that by saying sorted flag is false. And then we break. So this is the check if it's sorted. And if it's sorted, boom, we return after printing it's sorted. But if it's not sorted, then we have to sort it. And sort. Okay? And so we loop through the array. And if the element is greater than the next element, it's not sorted because we're sorting least to greatest. Then If this guy, then this guy. If we're not sorted, then sort. And then continue going through the entire array and check each time. And then if we want to count iterations, then we could create an int current iteration, and then we can increment current iteration because we had to sort, which means that we continued afterwards, and we run this code, and then next, and this would actually be created, this would be a while true loop. This guy's created outside, and then we increment it, so that way when we go again, we check. We're sorted. Are we really? Yes, we return. We're sorted. Oh, not really. We set to false because one of the elements was not sorted, or at least two of the elements were not sorted properly. And then, okay, we don't return, and then we loop through and we swap, and then we swap where we need to sort, and then we increment the current iteration again, and then continue. So that was bubble sort, and the improvements we made were, whenever we bubble an element to the end, so like, let's say our biggest element is the first element in the whole array, but we're sorting from least to greatest. So, small to big. We see that the element is bigger than the next element, so we swap it. We see that the element is bigger than the next, swap, 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 swap. So the big element, the biggest element, or whatever, our biggest element each time gets moved to the end. And then eventually we keep swapping, keep swapping, keep swapping until we find the biggest element, and then, it gets swapped until it gets to the end. So the end starts going in order. So like if we had an array from 0 to 100, when we find 100, it would eventually get bubbled to the end, and then the next time it would be 99 getting bubbled to the end, and whatever. So it'd be 100, 99, 98, 97, 96, 95, etc., all the way down to 0, right? So one thing here is that each time we loop through the array, we don't need to check the end. All right, well, I gotta go.